I was in the middle of filming part 3 of my series, printing some parts for the project, and when I came back, disaster. Spaghetti everywhere. I failed print. But it wasn't just any failure. Somehow, filament got stuck into the fan that cools the Hotend. That probably caused the fan to stop working, which led to heat creeping up the nozzle and clogging it completely. At least that's my theory. And here's the worst part. This printer is the only one I have for this channel. If I want to keep making videos, I have to fix it. So in this video, I'm taking you through the entire process, figuring out exactly what went wrong, troubleshooting, and hopefully fixing it. You'll see the problems I ran into and how I solved them, and maybe even learn something that could save you from the same headache. The first thing I noticed was filament everywhere, a complete mess of failed extrusion. That wasn't surprising, but then I saw something worse, a piece of filament stuck inside the cooling fan. That must have stopped it from spinning, and without proper cooling, heat likely traveled too far up the Hotend, softening the filament too high and causing a clog. When I tried printing again, nothing came out. Even when I manually pushed the filament, it wouldn't budge. I then tried pulling it back, but it just snapped inside the Hotend. At this point, there is no way around it. I need to take apart the Hotend and figure out how to unclog it. Let's get to work. So guys, this is my original Prusa i3 printer, the MK2. It's a printer I have had for quite a while. It's a very old printer and it served me really well. Recently we've been doing some videos. The project we've been doing, we've had quite a bit of trouble. Printer have had several issues with the bed and also the nozzle. I've been lucky to have worked out all the issues so far, but I think we've got a quite critical issue right now. I hope we can get the nozzle unclogged, or like we can save it somehow. But yeah, to continue making videos, I really need this printer right now. Since this is an older printer, I would need to lubricate all the moving parts because it has been sitting for a while. It didn't receive that much love, to be honest. And I need to clean it, dust the things, dust all the dust off, and yeah. Let's try to fix this and see what we can do. I started disassembling the Hotend, beginning with the nozzle. Once that was removed, I loosened the screw that applies pressure to the filament feeder. These screws are spring-loaded, and while I'm not sure exactly how tight they should be, I usually tighten them just enough, not too much, but not too loose either. Next, I removed the filament spool. Then I moved on to the side fan. There are 4 screws holding it in place, so I unscrewed all 4. One of them didn't go all the way, which makes me think I might have used the wrong screw when assembling it. All the screws are supposed to be the same size, so that's something I'll need to check later. Look at all that dust. Yeah, it really needs cleaning for real. We'll get to that. After that, I removed the plastic air directing shield. That's the piece that directs airflow under the nozzle and cools the PLA filament, followed by the PLA cooling fan. The fan is held by 2 screws. Unbolting those and it comes right out. The fan does not look that dusty, and I don't use that much PLA filament. Maybe that's why. After that, I took off the last plastic shield, fully exposing the nozzle. Right away, I noticed a buildup of dust, which definitely needs cleaning to ensure proper cooling. But more importantly, I could already see the real problem. There is a noticeable amount of plastic between the nozzle heat plate and the heat sink. This is where the heat break sits, and ideally no plastic should be visible here. This confirms what I suspected. Heat must have creeped up into the heat break, causing the filament to soften and clog the system. Now, the next step is to clean the nozzle and heat break through fully, to remove any melted plastic and get the Hotend working again. It was time to remove the Hotend assembly, but it was really stuck in there. I struggled to get it out, so I started removing more surrounding parts in case I had missed something. First, I remove the screws holding the timing belt. These actually just secure the X-axis plastic cartridge to the Hotend unit. Then, I unscrew the final X-axis screw at the top, allowing me to separate the Hotend assembly from the X-axis rail. I also cut the zip ties holding the linear bearings. While I'm at it, I'm definitely going to lubricate those bearings and rods. They feel rough and could use some love. After that, I remove the timing belt from the X-axis unit. Next, I took off the extruder stepper motor, which is held in place by 3 screws. Even after all that, the Hotend was still stuck. I had to use a flathead screwdriver to carefully pry it out. That finally did the trick. I did chip a small part of plastic from the air fins, but it's not critical, nothing major. With the Hotend out, I unplugged the heater cartridge and thermistor. And finally, there it is, the whole Hotend, out of the printer and ready for inspection. It looks really dirty, so I'll clean off all the burnt plastic while I'm at it. Hopefully, I can bring it back to working condition. Now, normally this is where you'd use a heat gun to warm up the Hotend and begin unclogging it. I don't have one, so I'm using a lighter torch instead. This is dangerous, don't try this at home. Always use the right tools. I'm a professional and I know what I'm doing. I started by heating the heatsink and then gently twisting the heater block. That allowed me to unsecure the heat break from the heatsink. It worked like a charm. Then I separated the heat break completely. At this point, I considered removing the heat break from the heater block, but I decided not to. My main goal was to unclog it. I moved on to removing the PTFE tube, which was completely stuck. At the end of it, there was a blob of filament, totally blocking the path. The heatsink must have overheated and melted the plastic right between the PTFE tube and the heat break. I used the torch again to heat the heatsink, just enough to soften the plastic and loosen the tube. It took a bit of finesse, but eventually I got it out. I had to switch to a larger torch to get it hot enough, probably because I use ABS, which needs more heat to soften. ABS melts around 190 degrees while PLA starts softening closer to 60 degrees. So there is a big gap between those. So if you're unclogging a PLA filament, it would be much easier and you need to use much less heat than me. With the PTFE tube out, it was time to unclog the heat breaker itself. I tried heating it first, but the melted plastic inside was sticky and stopped burn. I even broke off some of it that had leaked between the heatsink and heater block. You can clearly see how the filament is blocking the heat breaker. Here is the heat breaker going into the heat block. On this part where the heat block is, it's okay to have melted plastic. Then we have the middle part, which is between the cold end and the hot end. This other part supposed to go into the heatsink, and this is supposed to be the cold side. There shouldn't be any melted plastic on this one, and the fan is supposed to cool this part so that the plastic doesn't melt. Then I grabbed a 1mm drill bit and used it to carefully drill out the plastic inside the heat break. That worked much better. The hole is very small, so you need a really tiny bit. My 2mm bit was too large. It went in a little but couldn't pass through. After switching to the 1mm bit, I was able to drill all the way through. Still, the filament wouldn't slide through. Turns out there was some plastic clinging to the inner walls. I used the same drill bit to scrape along the side gently until everything came loose. And finally, success. The filament now passes through the heat break smoothly. That means the clog is cleared and everything is looking good. As a final touch, I use my Dremel to clean up the heat plug, removing all the burned on plastic. It came out really clean. Not as shiny as before, but I actually kinda like the matte finish. It feels like a brand new part. And there it is. We've unclogged the nozzle. I don't know if it's gonna work or it doesn't, but so far so good. I don't have any other PTFE tube, but for now I think this one is okay. So I'm like, when I assemble this, I'm gonna use the same PTFE tube and we'll see how it goes. And thank you for watching, and I'll see you in the next one.